Welcome to today's webinar. The topic today is modeling and design of steel structures in RFEM 6. Today we present the first part of the webinar, modeling and load input. And next week follows the second part with the design and so on. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. For instance, technical contents of the website, German and English webinars, newsletters, customer projects, and so on. I will be the moderator today and also the presenter, and I will be supported by my colleague Niklas Wanke. Niklas, you can introduce yourself.
Thank you, Andreas. Also welcome from my side. My name is Niklas Wanke, and I'm responsible for customer support at Dlubal as well as for product development in the steel construction sector. And I will answer your questions today.
Okay, thank you for your introduction. Then we can switch off our webcams that the attendees can see the full screen. You can ask questions when you click on that button. And then you can enter the question here and press send. And then your question will be sent to Niklas and Niklas will answer you. You can also watch the entire webinar and then email questions to info@dlubal.com. And then you will get an email with your answer. To the agenda today, at first I will model a steel structure, and before I do that, I will import a DXF file as background layer. And then the modeling starts. Then follows the load input, and I use also the snow and wind load wizards and the GeoZone tool from the website. And I will overtake the values for a certain place. And the last topic today is the application of imperfections. Okay, that's all for the content. Now we switch to the program, RFEM 6. So we start by creating a new model with clicking at this button or with File New. I call it Steel Frame. We use a 3D model and we only use members, but surfaces and solids that are also available in RFEM 6 can be checked on. That's no problem. So I switch to add-ons. We need to activate the steel design add-on, and we would like to use the combination wizards and the load wizards. So under standards, we can find the different international standards for the load case classification and the combination wizard. We use the Eurocode 0 and the German National Annex. And for the load wizards, we use the Eurocode 1 and also the German National Annex. And nearly the same for the steel design. We use the Eurocode 3 and the German National Annex. In the next dialogues, we don't need to set anything, but for the model parameters, we import model parameters from the GeoZone tool. I click on that field here and on the button with the 3 dots. And we need to select a location. I enter the location Munich. Okay, and we can zoom it a little bit in. Where's the snow load zone 1A? And for wind, the wind zone 2 with the values that we later use in RFEM. in the load wizards. Okay. You can see Munich, and the altitude is 530 meters. Takes some time. Okay. That's all for the dialog new model, base data. So then we would like to import a background layer. You can find in the navigator data the guide objects. And here at the bottom, the background layers. And with a right click, I open the context menu and I select new background layer. I need to import a file, a DXF file. So that's the steel frame DXF file that was created, for example, in the CAD program. Now, sometimes it can happen that you have to rotate it or something like that, or you can scale it. In my case, I have to rotate it around the y-axis 180 degrees. And now it's okay. But I would like to move the background layer. The column of, or the base of that column should be in the 0, in the coordinate point 0. That's why I double click on the background layer. Then I select the base of the column and the 0 point of the coordinate system. And now you can see I have it there as I wished. Okay, then we can start with the first member with that button, new single member. Before I do that, I delete the materials that the program remembered from the last entries. So we want to start at the 0 point. Okay. So then new single member. We would like to start with the column. It should be a beam. Where different member types. Later we will use another member type, the tension member for the bracings. Now we start with a beam and a section, a new section. Let's open the section library. That's a quite huge database. For the steel cross sections, usually we use the thin walled or the standardized. I use the standardized I-beams. I click on it. And for the column, the HEB 240, I have to create a new material. I use the filter European Union, steel, carbon steel, and I scroll a little bit down, steel S235. Okay. Okay, so, and I start with the first column. Okay. So, and I can see I would like to rotate it around, around the member axis 90 degree, because the bracings will be here in that field and in that field later, and the frames should be in this direction, in the Y axis, in the Y, in that direction. Okay, so I double click on the member, go to section, and I enter the rotation angle 90 degrees. Okay, then left above the new single member program provides the same cross section. Okay, those are the columns of the frame. I forgot to rotate it. I double click on it and then I enter 90 as rotation angle. That looks good. I continue with the horizontal beams. So left above, new member, same section, rotation angle 0 degrees. So this one and this one. Okay. Then we continue with the supports. Left above, assign nodal support. So I click on Edit Nodal Support. The provided entries, the default setting is quite good for us. Support in all 3 directions and around the vertical z-axis, this axis, a typical Gable support. Okay. That's the first frame with supports. So let me copy that by selecting all. Then I press the Control key. You can see the plus sign. The copy function is activated. And without Control key, you would move the frame. But I press the Control key, and that's why we create copies. So then we continue with the main horizontal member of the platform. So left above, new single member, an HEA 220 section, new section. And I open the library again. So then I-beams and, as I said, HEA 220. So, and this time we would like to assign hinges at the start and the end. So we go to the table hinges and we create a new member hinge at the start. So around the local Y and Z axis, a typical moment hinge. Okay, the same at the end. Okay. So, okay, to have a better overview, I switch to the wireframe model, and left at the bottom, I switch to the navigator display, and for the members, for the members, yes. I activate the member outlines and maybe the section name. Okay. That's better for the overview, I think. So I copy that member with the Control key to this side and to the side. So then the purlins, or we continue with the purlins of the roof, this one. So left above, new single member. Again with hinges, the same hinges, but another section. Open the library again, standardized I-beams, IPE 240. Okay. Okay. So let's take a look in X direction. So, and you can see the trapezoidal sheet will lay over this purlin and also over this purlin, and we also create a purlin in the middle in the next step. But at first we have to rotate this purlin. So that's why I change the work plane to YZ above. You can see the work plane. So view in X direction. And I create a line, a help line in that case. Left above, new line. So, and you can see when that at the bottom, the toggle auto mode is activated, you can draw an orthogonal line. If it's deactivated, you can't do that. So I activate it. So, and I create here left at the bottom an angular. So I select this member, that line. Okay. 2.86 degrees. So, and now I rotate that member, I double click on it. Now I can enter 2.86 here, but there is a second way to determine the degree. I measure it. So the angel vertex, then the first endpoint and the second endpoint, and you can see, that's the same value. So we overtake it with OK. And the purlin have been rotated. So we can delete the help line. So, and then I'll rotate it like this. I copy it with the control key. That was wrong, sorry. To the other side. And we would like to, to create a purlin in the middle of that horizontal beam between the first and the second purlin. So that's why I divide the horizontal beams by selecting them. Then I do a right click, members, divide member, and intermediate nodes. I divide it one time, and I select create on member nodes without dividing a member. Okay. You can see the node, but the horizontal beam is not divided. So then I copy that one to the middle and I copy all to the next field. Okay. That looks already quite good. Let me select the platform, and right above I select visibility by select and related objects. I go in the set view, and I can also, I go to the navigator display again, and I deactivate show hidden objects in background, and then the purlin will disappear. Okay. So then the next member, new single member. Again with hinges, but another section. I go a little bit quickly through it. IPE 160 this time. Again the same material. So, and those are more than one. I could also copy one, but there are not so many beams. That's why I draw them. Okay. Then I continue with those members. The main members under the silo. Left above, again, new single member. And another section. HEA 200. So the first and the second and these ones. All with hinges. So then I continue with these platform members. The section that we already used, IPE 160. Okay. So, and then we continue with that diagonal beams. A new section. HEA 140. Again with hinges. Okay. You need to check if the holes are matching. For example, if you go to the transparent model, that looks quite good. So we cancel the visibility mode, and maybe we go back to the wireframe model. What is still missing? The bracings. So new member, as a new single member, left above. This time member type tangent, and a new section. Go to the library again. This time not I-beams, but L sections. L equal L 60 by 60 by 6. Okay, this one. Okay, that looks quite good. So I copy all to the opposite side. And yeah, for the next platform, I would like to introduce you a new feature. If you have more than 1 or 2 bracings, you can use that function. You can find it under Tools. Then generate model members, bracings in cells. You have to create a new member or select an already created member or section. So, and then left at the bottom, you have to click that button and you can choose your cell. I choose these 2 cells. Prove it with OK. So, and the bracings are created. Okay, so we use for the platform this function, connect selected lines, members, and surfaces at intersections. Later, for example, we would like to support this horizontal beam by the platform members. Yeah, and that's why I divided the member. And we create now member sets for the columns and these main beams. So we start with the columns. Let me create, for example, a selection or selection. I activate object selection. I choose members by section. Okay, and I see only the frames. So I select all columns. And I right click on one column and then I select members. And then I click on create member sets. And 6 member sets were created. So then we continue with the HEA 200. I have to do it with 2 steps that we don't create only 2 member sets. We would like to create 4 member sets. That's why I select the left side, do a right click, members, create member set, 2 member sets, and then I select the right side, do a right click, and I create member sets again, 2 member sets. Okay. Right above, I cancel the visibility mode. Yeah, the model is now created. Let me go to the navigator display and I switch off the section name. Yeah, and also the member outlines. Okay, then we continue with the loading. The self-weight load case is already created automatically. Let me edit the self-weight load case. Action category is permanent, that's okay. And also the self-weight of the construction is activated. Now I can cancel that. So, and we start with the roof load, with the trapezoidal sheet that lays over the purlins. I go to Insert in the menu, Insert, Load Wizards. member loads from area load wizard. So the set direction, set A, is okay. Typical graphic for self-weight loads. That's the other load. Now, for example, for snow in set direction. So yeah, that should be the weight, 0.15 kilonewton per square meter for the trapezoidal sheet. I have to select the geometry. For edges, I have to select. Okay. So, and I would like to remove members from the loading that are parallel to that horizontal beam. Okay. And now I can create the load. So that's the surface load, and I can display all separately. And yeah, those are the created member loads. That's the load that will be transferred from the trapezoidal sheet, the self-weight of the trapezoidal sheet, to the purlins. So I can switch it back. Yeah. So then we continue with the platform. I select only the platform. And then I show only the platform members. So, okay. So, yeah, the next load, the load for the platform, for example, for steel plate that lays over the platform beams. I go to Insert, then Load Wizards, Member Loads from Area Load Wizard, the same wizard, self-weight, another load magnitude, 0.5 kilonewton per square meter. Okay, then I have to select the geometry. I do it in 2 steps. So that rectangle and then this area here. Okay, so we would like to exclude members again that are parallel to this one. Yeah, the steel plate should span in this direction. So I press OK. So, and the load was created. I can display it separately that we can see the member loads. That looks quite good. So I display it as the face load again, that we get a better overview. So then I cancel the visibility mode. Yeah, the self-weight of the construction or the self-weight load case is finished. We continue with the self-weight of the silo. The self-weight should act in the middle of that diagonal beams. So I create a new load case, self-weight load case, but I call it self-weight silo. And I don't activate the self-weight of the construction again. Okay. So I go back to the set view. I could divide those members and create nodal loads. Well, I don't do that. I select all of them, not this one, not the purlin. I have to do it in more than one step. Okay. And then I enter a new member load in Z direction, but not uniform, but concentrated. The load should be 4 kilonewton and it should be in the middle. That's why I enter load distance 50%. Okay. That looks good. Then new load case, the imposed load. I do it another way this time. I don't create a new load case. I go to the navigator data, left at the bottom. So, and I search for the load cases, and I can go directly in one load case or in the load case in combination dialog. In the second part of the webinar, I just explain something about the tables here. Now I go to the load case table and copy the self-weight load case. So I change the action category imposed loads. I select imposed loads. I deactivate the self-weight and I call it imposed load. Okay. And now we can delete the roof load and we can double click on the load wizard, and I only need to change the load magnitude to 0.5 kilonewton per square meter. Geometry is the same. Okay, that looks quite good. So then we continue with the silo filling. I create a new load case. I call it silo filling. Okay, imposed load, it's quite important. And I press OK. So I go back to the view in Z-axis. I create a new member load. The program remembers the last entries. I can overtake all, but I change the load magnitude to 10. And I have to select the 4 members. Okay. That's the silo filling. Next load case, snow. Above, new load case. Action category is snow ice loads. I call it snow. Okay, and now we use the next load wizard. I go to Insert, Load Wizards, Snow Load Wizard. Okay. There are different types of for the roof, flat monopitch that we use, and there's also dual pitch available. So I need to select the roof corner nodes. Okay. I have to exclude members from the load again. Members that are parallel to this one. Okay. And then I switch to the parameters, and the program overtakes our location from map and parameters. The other way is to use user-defined values, but we would like to overtake the map parameters. You can see the load zone, characteristic snow load, altitude, and so on. So then we switch to load cases. We already created the snow load case, and I press OK. So, and the snow load was created. Display separately. Yeah, that looks quite good. So then we create the next load cases. I go to new load case. We would like to consider 4 wind load cases: the wind in plus X direction and the wind in plus Y direction, with wind pressure and wind suction. So I at first I changed the action category to wind, and I call it wind in X and pressure, X plus. So then I copy it, WX minus, then I copy it again, WY plus, copy it again, WY minus. Okay, and I switch to the first one, and I start with the loads on the silo. I would like to consider the wind on the fully closed plane or area, and additionally the moment from the wind of the silo and the horizontal loads. That's in that area a doubled load, but I would like to consider also the horizontal load at the beams and also the vertical load from the wind that we get from the moment that we get from the wind on the silo. So I start with the wind in X direction. So that's a good view. Left above, new member load, concentrated load, this time in X direction, and load magnitude 2. 50% is the load distance in the middle. So all 4 beams. Okay. So then the vertical load from the moment, I go to new member load, this time in Z direction, load magnitude 0.5. Okay. And I assign it to this 2 beams. So, and in the next step, new member load, I add a minus, and I select these 2 members. Okay, that's all for the load in X direction on the silo. So we have the same load for that load case. Now, how we can copy that easily, for example, in the table, I switch to loads, member loads, sorry, I have to switch to the first load case, member loads, and I need to copy or select these through lines with the Shift key. I select all, then I do right click and copy them, and then I paste them to that load case. So now we have the same loads for both load cases. So then the wind in Y direction. So new member load, 2 kilonewton in Y direction. Okay, all the 4 diagonal beams. Okay, so then in vertical direction, new member load, 0.5 in Z direction. Okay, all 4 beams. Sorry, that was wrong. Only these beams. Okay, and new member load minus 2.5 kilonewton on these beams. Okay, then same procedure. I copy all the 3 lines, copy in the next load case, and paste. So then we continue with the wind load on the whole structure. We go to Insert, Load Wizards, and this time I use the wind load wizard. Okay. Also different types, and we use the vertical walls with flat mono-pitched roof. So then I have to select the base corner nodes. So okay, and the roof corner nodes. So yeah, if I had 2 screens, or I could show you 2 screens, then we had a better overview. We want to consider the load in the X direction, that means BC, and also in Y direction, that means CD, and that's why we deselect these walls. So then we switch to the parameters. Now we overtake the parameters from Munich, the load zone, and we have to assign the right load cases. BC, that should be the load in X direction. That's why I select load case 6, then load case 7, load case 8, and load case 9. So then I create the load. So that looks quite good, but let me display the loads separately. Yeah, actually we would like to assign on the load to the columns only and to the roof. Yeah, we would like to assign a horizontal load to the platform beams and so on, because the sheeting of steel plates is quite stiff. We would like to assign only the wind load to the columns and to the roof. That's why I double click on the load. Oh, that was wrong. That was a member. I double click on any load. So, and we would like to exclude members that are parallel to this one, to this beam and this beam. Okay, then let me check. Okay, it looks quite good for the columns, but the load on the roof is missing, because the purlin is parallel to that platform beam. How to correct that? I double click on any load. And we create another list. I copy that list and I switch to the type flat monopitch roof. The same directions. We need to exclude other members, only this member, that we get the load on the purlins only. So, same parameters, same load cases. Okay, that looks much better. Now we have got the load on the fully closed structure, on the columns and the roof. We can don't display it separately. So let me go through all the 4 wind load cases: YX, wind X plus, wind X minus, with suction, and these 2 load cases. Those are actually the same, but we leave both in our list. So then we continue with the imperfections. I go to the navigator data, or we are in the navigator data, and I select imperfections, and I create with a right click a new imperfection case. I call it imp plus X, and I would like to assign all imperfections that are in X direction to these 2 wind load cases. I double click on the 2 load cases. That the imperfections act only with that, in combinations with that wind load case, and not with wind loads in Y direction. So I create a new load case. I call it imp plus Y, and I assign them to the wind load cases in Y direction. Okay, that's all for the imperfection cases. And you can combine more imperfections in one imperfection case. I can create a new member set imperfection by right click on that new member imperfection, or I can choose that new member set imperfection. But before I do that, I switch to the navigator display, and I select or let display the member axis systems, that you can see those axes, and you can assign the imperfections in the correct direction. So I switch to new member set imperfection. in the imperfection case in X direction. I choose an initial sway, definition type, Eurocode free. So, and now the direction, the imperfection should be in X direction, in the global X direction, and that means that is in the local Y direction. Local Y. Then I need to measure the structure height. Okay, there are 3 members in one row. 1, 2, 3. And that's all. I have to select the 6 set of members. Now I select the pointed line. Okay, and above I would like to show the imperfection. So that's good. Then next member set imperfection. This time in the other imperfection case, also an initial sway according to Eurocode 3, and this time in plus Y direction, the global plus Y direction, and that means minus set direction of the member. Minus set 6.78 and this time 2 columns in one row. And I have to select all the 6 member sets. So then I have to switch to the imperfection case Y. And you can see it's the correct direction. Okay, that should be all to the first part of the webinar. Next week we go in the combinatorics. We do the steel design, documentation, and so on. I also consider the stiffness of connections, of that frame here. I do also an optimization. We see each other or hear each other next week. Bye bye.